All right, Adele, I'll let you get started. It's 9:30 p.m. my time. It's whatever 30 p.m. your time. So let's get started. Welcome to Microsoft JD Conf. We'll see
Thank
you
you.
in 25 minutes.
Yep, wonderful. All right, so thank you for that awesome introduction, Bruno and Max. And if you did just join the stream, my name is Adele Carpenter, and I'm a software engineer at Trifork Amsterdam. So a quick note about Trifork. Trifork was founded in Denmark in the 1990s and now has offices throughout Europe and a couple even beyond that. Each location has a slightly different focus, but what we all have in common, which I think a lot of people here at this conference today, is a passion for building great software. The Amsterdam office that I work in particular is very much a Java shop, and I actually spend most of my days building and maintaining Java applications in the educational sector. So quickly before we go on, I would just like to share the format of today's talk. It is probably a little bit different to the other talks that you have seen so far in this conference. I'm going to be exploring a case study in a storytelling format. Then we'll pull out some lessons that we can apply to software development. So there's a little bit of drama and you need a little bit of imagination. So let's go. It's 5:05 p.m. on a cold evening, a few days after Christmas in 1978. The crew of United Airlines Flight 173 are preparing to land a fully laden DC-8 in Portland, Oregon. It has been an uneventful flight for the passengers from Denver, despite the usual Christmas chaos at the airport before departure. First Officer Rod Beebe, age 45, is the pilot flying. And although he is an experienced pilot, he is relatively new to the DC-8. This is a large, narrow-body aircraft with 4 jet engines and seating for approximately 180 passengers. It's a career milestone for him, which makes it almost worth being away from his young family so soon after Christmas. He's now down to an altitude of 10,000 feet, so he asks his captain and friend, Melbourne McBroom, to lower the landing gear. McBroom obliges. Suddenly, a loud thump echoes through the aircraft. This is followed by a jarring vibration and a sudden pull of the nose of the plane to the right. Beebe and McBroom scan their instruments. The gear light is not illuminated. So unless the light is malfunctioning, that means the gear is not fully extended. An error deploying landing gear would explain what their sensors just told them. "What on earth was that?" yelps Second Officer Forrest Mendenhall, who goes by the nickname of Frosty. Beebe and McBroom look at Frosty and then back at each other. They both know that landing without the main gear is an extremely risky maneuver that could easily result in disaster. It's time to put their training to use. Captain McBroom radios Portland Airport approach and tells them that Flight 173 will be staying at 5,000 feet and entering a holding pattern while they attempt to resolve the issue. They'll keep the speed steady at 170 knots. "We've got a gear problem. We'll let you know." Portland provides a heading for the hold. Over the next 25 minutes, the 3 men discuss and accomplish all relevant emergency and precautionary actions in an effort to reassure themselves that the gear is in fact down and locked. Frosty even enters the cabin for a visual confirmation of the wing indicators. They pop up when the gear pops down. It's dark by now, but Frosty can indeed see them easily. Frosty re-enters the cockpit to find the Captain McBroom discussing the likelihood of an emergency landing with the head flight attendant, Joan Wheeler. An old-school gentleman, the captain doesn't want to frighten the passengers or hurry the girls, as he puts it. He tells the ground that he and his crew will take their time and get everybody ready before attempting a landing at Portland Airport. The ground keeps them in a holding pattern. Joan returns to the cabin and, in unison with the rest of the cabin crew, calmly begins taking steps to maximize the chances of survival in an emergency landing. She knows that the plane is in a safe holding pattern, so she can take her time and do everything by the book. In her 14 years as a United flight attendant, she has never had to prepare for such a landing, but she makes it look effortless. She patiently reminds people of the brace position. She asks able-bodied men to sit in front of the emergency exits. She instructs mothers on how to best wrap and hold their babies. She reassures children. And please do excuse me while I do perpetuate gender roles here, but it was 1978. In the cockpit, the three men continue exhausting all avenues to ensure that the gear is in fact down and locked. Yet, in between directions from the captain, Bibi and Frosty are passing each other increasingly worried looks. It's now 5:55 p.m. and Flight 173 has been in a holding pattern at low altitude with the gear down for 50 minutes. That's 50 minutes. Bibi asks Frosty, how much fuel is remaining. Frosty stutters, 4,000 pounds, one in each tank. Bibi does some quick math. At the current burn rate, they might have enough fuel for 18 minutes. At that moment, the approach tower advises the next heading. It's toward the airport. Bibi breathes a quick sigh of relief. Surely we're going in now. The captain, still focused on the gear, asks Frosty to do yet another sweep of the cabin to check how things are going. The captain's number one priority is a safe emergency landing with a fully prepared cabin. Absolutely no surprises. Frosty obliges, but he would prefer to be assisting the flight deck as they make the final preparations for landing, which surely must be only a couple of minutes away. Frosty returns to the cockpit at 6:01 and tells the captain that the cabin is 2 or 3 minutes away from being ready. But at that moment, he feels the plane bank to the left, away from the airport. Shit, he thinks to himself, another hold. But before he can say anything, the captain asks about the welfare of the passengers. How are they doing? Yeah, they're pretty calm and cool. Some are more anxious than others. I did my best to reassure them while I was back there. The captain replies, okay, well, 2 minutes before landing, about 4 miles out, pick up the mic and tell them to assume the brace position. Aye, aye. Frosty takes the opportunity, though, to gently remind the captain of the fuel situation. You know, we've got 3,000 pounds of fuel left and that's it. That equates to about 13 minutes. Without flinching, the captain advises Frosty what to do if the gear collapses on landing. 4 more minutes pass. The captain sucks Frosty and Bibi into further conversation about the emergency landing and whether the gear is down or not. Joan enters the cockpit and announces, well, I think we're ready. The captain acknowledges and advises that they'll be landing in about 5 minutes. While the captain wraps up the final details with Joan, Bibi addresses Frosty. Hey, buddy, I think you just lost number 4 engine. Joan thanks the captain and leaves the cockpit. Buddy, Bibi continues, I think you just lost an engine. This time, the captain is listening and he seems surprised. Why did we lose an engine? Bibi utters just one word, the concern on his face as clear as day. Fuel. It's now 6:07 and finally the captain asks for heading back towards the airport. The plane starts banking to the left. Engine number 3 stops. The official term is a flameout. Now the fuel situation has the captain's attention. He asks Frosty to open the crossfeeds. This allows whatever fuel is left to power the 2 remaining engines. The captain insists that the tank that was feeding engine number 3 must still have 1,000 pounds of fuel. Tensions heighten as the captain keeps barking at Frosty about the crossfeeds and the extra 1,000 pounds of fuel that doesn't exist. At 6:09, the captain asks Portland Approach for a final heading towards the airport. He does not convey the seriousness of the situation. The airport still expects a landing where the gear might collapse. Emergency services are standing by. He follows up by asking how many miles left they have to fly. The response is 18 nautical miles. That's 6.5 minutes. They have 5 minutes of fuel left, tops. Sure enough, 4 minutes later at 6:13, engine 1 and 2 begin to splutter. Flame out is inevitable. Finally, the captain declares a Mayday. Within seconds, the plane clips a tree and then another before plowing into some power distribution cables. The plane slows as the wires stretch before crashing into two unoccupied homes and coming to rest in a field. There is no fire, no fuel on board. Most of the 181 passengers on board, including a prisoner come fugitive, exit the plane physically unharmed. The fugitive actually helped people out of the aircraft before running away. The captain and BB are injured but alive. Frosty and Joan, along with 8 others, are dead. The next morning, the newspapers hit the stands. Without yet knowing what has happened in the cockpit, the media labels Captain McBroom a hero, citing the miraculous landing without injuries or deaths of people on the ground. Survivors praised the flight attendants for their preparedness and the orderly evacuation. It could have been a lot worse. But why did it happen in the first place? United Airlines Flight 173 is arguably the most important crash in aviation history. If you ever took a flight after 1985, then I guarantee you that your safety has been impacted by this flight. In the final report, investigators list the probable cause for this crash as well as a contributing factor. The cause was the captain's failure to properly monitor the aircraft's fuel state and to respond to both the low fuel state and the crew members' advisories regarding the fuel state. The factor contributing to the accident was the failure of BB and Frosty to either fully comprehend the criticality of the fuel state or to successfully communicate their concern to the captain. And the most alarming part of these findings were that they were not isolated. They were only the latest in a string of air crashes with similar causes. In the 1960s and 70s, the number of flights were growing dramatically, as were the number of crashes. So, for example, the most famous crash before Flight 173 was probably the Tenerife airport disaster in 1977. In this crash, 2 fully laden 747s collided on the runway, killing 583 passengers and crew. And in a similar manner to Flight 173, the probable cause in this crash was a breakdown in communication. Only this time it was both inside and outside of the 2 cockpits. Air traffic control also played a role. So, in this broader context, the findings of Flight 173 were timely. NASA had already identified the issue of human error in the cockpit and were working on a solution called Crew Resource Management, or CRM. Now, I know that hearing that acronym might make you shudder a bit if you ever worked on a customer relationship management system, but for today, CRM means Crew Resource Management. And in the investigation report of Flight 173, airlines were told to give this training to their pilots. Specifically, the crew resource management training should have 2 themes. The first is participative management for captains. In other words, providing a non-threatening environment that actively encourages collaboration. And secondly, assertiveness training for the other cockpit crew members. So how to get your point across effectively in a non-threatening manner. In modern organizational terms, you could summarize it as ensuring psychological safety in the cockpit, which I actually find really interesting as this recommendation predates the term psychological safety by about 20 years. What's also really interesting is the emphasis on the assertiveness of the co-pilots. So it's not just the responsibility of the captain to provide a safe space, it's the other crew members also taking responsibility for how their message or advice is received. And indeed, in the decades that have followed the implementation of CRM, starting with United Airlines, obviously, in 1981, indeed, the culture of aviators has changed markedly. It is no longer a case of captain knows best. Every young pilot knows no matter their experience level, that they not only have the right, but they have the responsibility to speak up when something is not right. Now, you could argue that in software, the stakes aren't as high as human lives. But what if your failure to speak up sparks a chain of events that result in a data breach, a loss of faith with a customer, or worse, a loss of faith in yourself? Of course, being prepared to speak up is different from knowing when to speak up. So, how can you better tell if things are wrong or require further examination? That decisions are being made that ignore key evidence? What can we learn from Captain McBroom? He can teach us a lot about situational awareness. This is a fundamental concept for aviators. Put simply, situational awareness is knowing what's going on around you. In the case study, we saw Captain McBroom getting increasingly fixated on the landing gear issue, which left him unable to process the criticality of the fuel situation. He had lost his situational awareness. And if you are the proud owner of a human brain, it is actually very easy to lose your situational awareness. So, for example, have you ever dived into an issue so deep and got caught in the technical wonder that you lost sight of what the problem was in the first place? Or you were so focused to getting to your destination on time that you failed to notice what a beautiful day it is? As an engineer, if you fail to maintain your awareness of your situation, you end up with a perfectly engineered feature that nobody wants, or a hot fix for a small ordering issue that leaves your app unable to process payments. So, how can we maintain situational awareness in our roles as software professionals? This is a list that I've adopted from crew resource management training, interpreted in the software engineering context. So, firstly, you can maintain situational awareness by considering the impact of stress and your workload on your performance. So, for example, how many tickets are assigned to you right now? How many meetings do you have planned? Which deadlines are real and which are arbitrary? Be honest with yourself and others on what you can accomplish. You can maintain your situational awareness by having an appreciation of the automation and abstractions present. So, are you aware of the abstractions that you interact with, even on a rudimentary level? Could you find the resources you need should the situation require it? Do you have a basic understanding of what happens when you run a job in Jenkins, for example, or what your delivery pipeline's doing? Or what's it doing and what could go wrong? Paying attention to and meeting your physiological needs. Did you sleep enough? Sorry. Are you hydrated? Did you eat? Did you poop? Recognizing that you carry around preconceptions and bias wherever you go. Is your gut instinct actually just bias? Why does a certain course of action appeal to you? What evidence do you have to support this position? What evidence do you have against? And being aware of your limitations, for example, as they relate to your abilities, experience, or training, and communicating them when relevant. So, what are your limitations or weak spots with respect to your role? How can you patch them? Who can help you? What knowledge could you share with others? And crucially, situational awareness it doesn't have to be a solo endeavor. Everyone has a role in maintaining the situational awareness of your team. So by encouraging an environment where everyone can speak up, share their knowledge and challenge ideas, then you lift the situational awareness of your team and your organization. In other words, your crew. And this, as has been known in aviation for many years now, leads to better decision-making and better results. Thank you. That is the end of my presentation. I know we're a little bit ahead of time, so maybe if Bruno's there, we can come in and have an extended Q&A.
Absolutely. That is a great plan. I took a screenshot here of one of your slides. It was my favorite one. Probably I should have taken more screenshots, but this one caught my attention. The one that you talked about crew resource management and the trainings that the captains went through, and also the crew members had to go through. And I think communication is key, right? One is like you say here, providing a non-threatening environment that actively encourages collaboration for the captains. And the other one for the crew members, how to get your point across effectively, uh, um, also in a non-threatening manner. Because the situation is stressful, you are on flight, and it's all about being receptive of whatever is being told at you, but also being effective at what you are talking. I will share a situation that happened to me at the beginning of my career. And you mentioned this with software. Yes, it is less likely there will be lives impacted by a mistake or a software issue, but there are actually real world consequences. And in my case, when I was beginning as a software developer, I made a mistake on a production database. And in fact, millions of dollars or local currency went to the wrong account. And that would have certainly impacted someone in a very bad way. I mean, financial loss it does have a huge impact, whether it's a corporation or individual, it doesn't matter, right? Luckily, that was discovered by the actual person or entity, the corporation that received the money that they were not expecting, and they reported back to the bank, and they said, "Hey, this money is not ours. Something is wrong." And at that time, it was one of the biggest lessons that I learned at that time was like to communicate as soon as possible. You see it and raise the issue to get it addressed. And when I was working in that production database, I felt something was wrong, but I thought, no, it's okay. And, it was not okay. And a couple of weeks later, the reality came up. So, being able to communicate as soon as possible, being able to communicate in an adequate way and really like identifying the problem and working to fix it. I think that to me stood very much from your presentation and also from my personal experience from decades ago. So interesting. Any real world stories you recall, like in software industry?
Well, actually, only recently I came through, let's call it the rite of passage that every developer needs to come through, which is making a mistake on a production database. That wasn't too long ago, so it's still kind of raw. But what came out of it was the actual collaboration with my team and also my customer. So we do work at Trifork with customers. It was actually my day off because I made the other fatal error of doing a change on the production database on my weekend, which is Thursday. So I get a call on Friday saying, "Hey, I'll come in or jump online." But the thing that came out of it was there was no tearing down. There was no, "Hey, Adele, you made a mistake." There was nothing like that. It was, okay, this is the situation right now. What can we do to fix it, to get things back up and running, revert to a previous version? Got that up and running. And then the next week, we had a bit more of a, I guess you call it a post-mortem. We called it a retrospective. I don't think it really matters. We actually spoke about what happened and what were all the things that contributed to that situation happening. And my team's so great. It wasn't just me. There were a couple of things that the team kind of missed as well. And when you combined all those things together, then that was what caused the production database issue. And that's really the model they work with in aviation, is there's very rarely one single cause, very, very rarely. Even if it comes down to pilot error, which a lot of them do, it's because a whole lot of things that were maybe unexpected all happened. It's like a Swiss cheese model. Eventually everything lines up and you go straight through.
Yeah. I mean, in my situation, it happened when I was called into the office at 3 a.m. to fix a migration. And so it's just a spiral of errors, migration being done at the wrong time with the wrong tasks, and then somebody is on call and they have to come in the middle of the night to fix the migration and fix something, and mistakes are more likely to happen. So definitely relate to that. Can you just stay around? I want to wrap up our this presentation, but please don't disconnect. So thank you so much for being here with us.